Hi everyone, my name is Aditya Vansal and I'm here to present to you our tool, which is Correct Image Product Representation, or CIPR for short. We have built the tool in such a way that it will be the only tool that you require to ensure that the product listed on your platform, e-commerce platform, is the correct product. Let's move on. So our solution aims to check each product image for any discrepancy with respect to the product name and description. With e-commerce platforms on a rise, it is important to maintain correctness of image products to save customers from being deceived. Next, we have a walkthrough of our product map. We start from right here. When a merchant enters a new product on our e-commerce platform, or an individual user uses our tool to check the product if he is buying is correct or not, the tool first checks for image quality. It does so by two techniques within the BRISC model. The first one is natural scene statistics, and the second one is mean contrast normalization. Essentially, what the BRISC model is a tool which calculates no reference image quality score for image A using the blind referenceless image spatial evaluator. This is a special Python script that allows us to rate the image on a scale of whether it is clear or not. In case the image is not clear, we automatically know that it may contain a product which is malicious. If the image is above a threshold of quality, we next check for the image background, number of objects in the image plus noise in the background. So let's say that the product listed on a platform is a rugby ball. In case there are many more balls in the product image with the rugby ball, then the user who is buying the rugby ball may not know which ball it is and may be misled due to the number of balls in the image. So it is important to check whether the number of objects in the image are higher than a threshold. Secondly, we also check for noise in the background. If the image is noised or hazed, then the user might not get the correct perception of the product being sold. In case this is right, we next move on to cleaning. We next move on to altered visuals. But what I mean by altered visuals is all kinds of images which are photoshopped or which have been processed post having been clicked. To do this, we use metadata analysis, error level analysis, and GPS localization. Let me dive a bit deeper into these to help you understand what they are. So metadata is everything that is being collected on your phone when you click a photo. And so metadata has all characteristics like by what camera the photo has been clicked, where the photo was clicked, at what time it was clicked, and these are data points which can be used to identify whether the image is authentic or not. Next, we have GPS localization. If an image if a product being sold in India has been clicked anywhere else and has been has been processed on or has been photoshopped, then GPS localization helps us to identify such kinds of cases. Error level analysis allows us to check different compression rates within the image. Once an image has been clicked, it is compressed. In case it has been photoshopped or altered, the compression level of local areas within the image changes. This is what error level analysis helps us to identify. If the compression has been changed, then we know that the image has been photoshopped and is an altered image and not the real image. If all these checks are met with and if the image is not altered, then we move on to incorrect representation or mismatch. This is perhaps a most powerful tool. What this does is it takes the image and runs it through the World Wide Web. It checks for the kinds of results it gets back from the web. For example, if it is a cricket ball, then the cricket ball will go onto the World Wide Web, and if what we get back is a cricket ball itself as the text, then the NLP engine knows that what is in the product description, which is the cricket ball, and what we have gotten back from the web, which is also a cricket ball, is the same, and it can move on because the image representation is correct. If it is not so, then the system will raise a flag and the image will be rejected from the e-commerce platform. We have another layer of security measure, which is taking in user feedback in case an image is wrong. In case a user does give us the feedback that this image is wrong, we further check and put that into our system and train our model to be better in that way. And that is how the whole system works. I would also like you to meet the team next. So I am Aditya Vansal, the team leader and product and machine learning fellow who takes care of how the product is being represented and all the machine learning techniques that go into the product. Vanshaj and Kunal are brilliant machine learning engineers who ensure that the whole pipeline is smooth and the app is useful and working. Shubham and Tejasvi help us integrate our tool into each and every platform, build an SDK out of it. Shreya helps us to design each and every aspect of the Chrome tool that we are using. Thank you.